Hi my friends, today we go back to finite element analysis tutorials after we studied static force parts and all model variants in our previous tutorials. Now I choose this variant, which is static analysis applying a moment, and the subject is a part, not assembly. The part is this one, a ring wrench, very simple and without any flowers in Romanian, floricele. We don't add fillets, we don't make special pockets, and this is the recommendation when you apply finite element analysis, to have a part, a model as simple as possible in order to have the possibility to use the power of your computer without having to solve delicate problems. Let's model this part. Millimeters, XY plane, a circle in the center point with a radius of 16 as in drawing, and with an extension, a handle starting from the circle and coming to the circle. Good, you see this is horizontal, all tangencies, everything is okay. Trim this, the same horizontal for this point with the center point, and now the dimensions 160, home, and radius of 9, as you can see in the drawing. This is a supplementary dimension. Here we have a hexagon, a polygon with 6 sides, with this line horizontal, and the dimension of hexagon is 19. Okay, finish sketch, home, extrude, this, not the interior, at 4 millimeters as in the drawing. This is the part. We choose steel alloy like any wrench is. Now let's see what are the properties for you to compare when you create the model. Okay, and now we apply environments, stress analysis, create study. The study is static like the first one. Okay, we know all these steps. Now we look here to see that the material is okay and the override material is the same. Good. This is important to see what material you choose. Then we apply pin to this surface, but now we are careful to add fixed tangential direction, not rotating. We fix the rotation of this part of the wrench. Okay, this is the only constraint we apply. And now instead of force, we choose moment. Where is it applied? On the axis of this end of the wrench. And I think that the maximum force applied here is 500 newtons, and the length of the key is what it is, 160 millimeters. Yes, I think that 50 kilogram force is a very strong force for this wrench. Okay, now everything is prepared to apply the simulation. Run, and we see how it looks. If we animate, we know what happens, and you can see here the stress all around the part. The maximum is somewhere here, yes, where is red, and now we have for Mrs. stress. Okay, we go to displacement, but it is visible, no problem to see where is the maximum displacement. Here around let's apply maximum, yes, 2 millimeters. This is important, yes, important displacement. But, and this is what I didn't tell you till now, the important result is the safety factor. As you know, the safety factor measures how a material in a specific fashion or form responds to the stress. We see the maximum is here, but in opposition with the stress and the displacement, the bad thing is on smaller values. Here we have 0.49. This is very low. This means that the wrench will be broken. Yes, so we have to add the minimum value of this factor, which is here, and we can animate everything to see what happens. You see the values, the modifying values of minimum and maximum. Yes, this is the place where this wrench will be broken. Oh, this is that we have to take care. Yes, what we can do with this part, this thin part? Well, we think to increase the thickness. The first thing we think, not changing the form, but changing the thickness. We go back to the model, double click on extrusion, and we choose 6 millimeters, for instance. OK. And now we simulate again. We apply safety factor, and we see that 0.74 is the new minimum value of the safety factor, which is also important because it's smaller than 1. When the value is 1, we are sure that the wrench, the model, does resist to the moment. This is why we have to increase again the thickness. We apply 10 millimeters. OK. Again, simulate, run, and now we see that the minimum is 1.23. For you to know, there are a lot of situations in the mechanical engineer area of interest. When you design a plane, the safety factor is as minimum as possible, because you don't want to fly with a great weight. But when the design is for a locomotive, yes, a locomotive for train, the safety factor is over 15, because you want the locomotive to be very heavy in order to carry a number of wagons. Yes, between these two different situations, when safety factor is from 1.5 to the plane and 15 to a locomotive, you have a large range of possibilities. For us, 1.29 is not acceptable. This is why we go back and we choose, say, 12 millimeters, the thickness, and then I hope that we have a greater safety factor. Safety factor is what we focus on, and this is 1.52. It is still small, but you can go with this procedure to create your own variant. Another thing very important here is when you choose another material. When you choose an override material, not steel alloy, but say brass. Why not? Okay. When you simulate again with this new material, you see that the safety factor is again under 1. You have all the possibilities to make other modification to dimensions or to material, so obtaining what you want. Let's choose another material, a steel, a special steel, high strength, low alloy. Okay, why not? This is a joke for us. Simulate, apply, safety factor, and we have 1.67, more than 1.50. So after you finish everything here, you can add pockets, for instance creating a sketch here with some slot, center to center, from this point to this point, and so finish sketch. Yes, I have to dimension it, say a radius of 6 and a length 130, fully constrained. I choose this point in the center of the end. Finish sketch, apply an extrude, cut, not join, of 2 millimeters. Okay, a fillet of 1 millimeter, and also at the back. Okay, nice. And another fillet of 0.8, all fillets. Not all fillets, all rounds, all over the part. Okay, we also add a hole here in order to put the part somewhere in your shop, workshop. A hole here, on the center of, say, not metric but 6 millimeters, no, 8 millimeters. We design just now everything here, and now I want to place this pocket on the both sides. I go back to the extrusion and I choose here symmetrical. Symmetrical about what? About the plane XY. Why to do this? Because now I apply mirror. I always forget this. What features? The features are this, the extrusion, okay, about the XY plane, and we see that they will appear here. Okay, that's right. Now our ring wrench is more nice. If we apply again stress analysis, simulate, run, we see that the time is longer because we have so many improvements here, and stress safety factor is again below what we want to be. Sure, you can modify the sketch with the 11 millimeters here, and then I hope, together with you, my friends, to have a better situation. Safety factor now is 1.05. You are free to try to make any other modification in order to have a proper part and to enjoy what you do. I wish you good luck and have a nice time. Bye bye.